Welcome to the next section of this course, Becoming a Delphi Language Ninja. We'll start off by having some fun with anonymous methods using higher-order functions. We will then write enumerable types. Further, we will configure the class at runtime and perform duck typing using RTTI. In the end, we will create helpers for the classes. So let's begin with the first video of this section, using higher-order functions. In this video, use Delphi's anonymous method with some of the most popular and useful higher-order functions. Since version 2009, the Delphi language, or better its Object Pascal dialect, supports anonymous methods. What's an anonymous method? Not surprisingly, an anonymous method is a procedure or a function that does not have an associated name. An anonymous method treats a block of code just like a value, so that it can be assigned to a variable, used as a parameter to a method, or returned by a function as its result value. In addition, an anonymous method can refer to variables and bind values to the variables in the context scope in which the anonymous method is defined. Anonymous methods are similar to closures defined in other languages, such as JavaScript or C. An anonymous method type is declared as a reference to a function. Anonymous methods, or anonymous functions, are convenient to pass as an argument to a higher-order function. What's a higher-order function? Wikipedia gives this explanation. In mathematics and computer science, a higher-order function, also functional form, functional or functor, is a function that does at least one of these. 1. Takes one or more functions as an input. 2. Outputs a function. All other functions are first-order functions. Here are some of the useful higher-order functions which we will use with Delphi's anonymous methods. 1. Map. This is available in many functional programming languages. This takes as arguments a function and a list of elements list, and returns a new list with function applied to each element of list. 2. Reduce. This is also known as fold. This requires a combining function, a starting point of a data structure, and possibly some default values to be used under certain conditions. The reduce function proceeds to combine elements of the data structure using the injected function. This is used to perform operations on a set of values to get only one result, or a smaller set of values that represents the reduction of that initial data. For example, the values 1, 2, and 3 can be reduced to the single value 6, using the criteria of sum. 3. Filter. This requires a data structure and a filter condition. This returns all the elements in the structure that match the filter condition. At design time, our form will look like this with the buttons and T memo. For the higher-order functions.dproj project, the actual high-order functions are implemented in the higher-order functions u.pas unit as generic class functions as shown here. Let's analyze each of these functions. The map function requires a list of t parameters as its input data structure, and an anonymous method that accepts and returns the same type of data t. For each element of the input data structure, the map function is called and another list of data is built to contain all its results. This is the body of the map function. The main form uses the map function in this way. This generates some sample data. This calls the map function on the array of strings. This is the map criteria that will be applied to each item to capitalize the first word in the item. This is the related list box with the result. The reduce function requires a list of t as its input data structure and an anonymous method that accepts two parameters of type t and returns a value of type t. It can also be passed a default for each element of the input data structure. The reduce function is called by passing the intermediate result calculated so far and the current element of the list. After the last call, the result is returned to the caller function. This is the body of the reduce function. The main form uses the reduce function in this way, where this is used for the sum of input data using starting value to 0. The last implemented function is filter. The filter function requires a list of t as its input data structure and an anonymous method accepts a single parameter of type t and returns a Boolean value. This anonymous method represents the filter criteria that will be applied to the input data. For each element of the input data structure, the filter function is called, and if it returns true, then the current element will be in the returning list, but not otherwise. After the last call, the filtered list is returned to the caller function. Here is the body of the filter function. The main form uses the filter function to filter only even numbers. The code for it is as shown. This line gives us the even numbers. In the video's code, there are other utilization samples related to higher order functions. Let's run the application. Hit on F9 for running or go to Run tab and click on Run. When you click on Add Star, it will add some data to the memo. And when you click on Capitalize, it will capitalize all the starting strings. When you click on different buttons, it will show you the results as shown. Higher order functions are a vast and interesting topic, so in this video we only scratch the surface. One of the main concepts is the abstraction of the internal loop over the data structure. Consider this: by abstracting the concept of looping, you can implement looping any way you want, including implementing it in a way that scales nicely with extra hardware. A good sample of what can be done using functional programming is the parallel extension of the good OmniThread library, a nice library to simplify multi-threading programming, written by Primo Gabriel. You can refer to this link. This is a simple code sample that executes a parallel function for defining a simple iteration with an anonymous method and runs it using multiple threads. When the for in loop was introduced in Delphi 2005, the concept of enumerable types was also introduced into the Delphi language. As you know, there are some built-in enumerable types. However, you can create your own enumerable types using a very simple pattern. To make your container enumerable, implement a single method called getEnumerator that must return a reference to an object, interface, or record that implements 3 methods and 1 property. In the sample, the element to enumerate is tfoo. There are a lot of samples related to standard enumerable types, so in this video, you'll look at some not-so-common utilizations. Here, we will deal with the enumerable functions. The goal is to enumerate all the rows into a text file without actually opening, reading, and closing the file, as shown in this code. Nice, isn't it? So, let's start. We have to create an enumerable function result. The function simply returns the actual enumerable type. This type is not freed automatically by the compiler, so you have to use a value type or an interface type. For the sake of simplicity, let's code to return a record type. The T-file enumerable type is defined as shown. No logic here. This record is required only because you need a type that has a getEnumerator method defined. This method is called automatically by the compiler when the type is used on the right side of the for in loop. The T-file enumerator type is the actual enumerator and is declared in the implementation section of the unit. Remember, this object is automatically freed by the compiler because it is the return of the getEnumerator call, as you can see here. The enumerator inherits from tEnumerator string because each row of the file is represented as a string. This class also gives a mechanism to implement the required methods. The doGetCurrent called internally by the tEnumerator open bracket t close bracket dot getCurrent method returns the current line. The doMoveNext method called internally by the tEnumerator open bracket t close bracket dot moveNext method returns true or false depending on whether there are more lines to read in the file or not. Remember that this method is called before the first call to the getCurrent method. After the first call to the doMoveNext method, fCurrent is properly set to the first row of the file. The compiler generates a piece of code similar to this pseudocode. So let's see the result of our code. Hit F9 or click Run tab and run the code. You will see output in the command prompt as shown. Enumerable types are really powerful and help you to write less and less error-prone code. There are some shortcuts to iterate over in-place data without even creating an actual container. If you have a bounce or integers, or if you want to create a non-homogeneous for loop over some kind of data type, you can use the new T-array open bracket T close bracket type as shown here. T-array open bracket T close bracket is a generic type, so the same technique works also for strings. It can also be used for plain old Delphi object, PODO, or controls. Here is a link to the Embarcadero documentation, which will provide a detailed introduction to enumerable types. Awesome! This video helped us to write the enumerable types. In our next video, create a class and configure it at runtime.